Hello everyone, in this video I'm going to explain rules about differentiation. In this video I explain that 5 rules. So we started to study the first rule, differentiation of bracket power n. The power comes down, minus 1 from the power, multiply the derivative of inside bracket. We can see this example, y equals 1 over square root of 6x minus 3. First, we have to write the function as the rule. The rule is that y equals f of x to the power n. So we need to write this as f of x to the power. We have here a square root. Generally, the nth root of x power m equals the power inside over outside, m over n. The second thing also we need to revise, 1 over x power m, when we move x power m up, it becomes x power negative m. Let us start to solve this question. So, the solution is that y equals 1 over, if there is no power, it means 1. So this 6x minus 3, it means 6x minus 3 to the power 1. And this is a square root, it means the power 2. So the power inside over outside. Then the answer is here, y equals 6x minus 3 to the power half. This is the first step. Shift this up, so it becomes 6x minus 3 to the power negative half. Now we can apply the rule. So dy by dx equals, the power comes down, so this power comes down, so it's negative half bracket 6x minus 3 to the power. Negative half minus 1, negative 1 and half. Negative 3 over 2. Multiply the derivative of inside bracket. So multiply 6. Simplify. So we cancel 2 with 6 divided by 2 equal 1 divided by 2 equal 3. So the answer in simplest form is that negative 3 bracket 6x minus 3 to the power negative 3 over 2. So we differentiate. The second part, we need dy by dx at this point. At this point, it means we replace x by 2 and y. Just we replace x by 2. Because here in that function, in dy by dx, there is no y inside. So dy by dx at 2 and 1/3 equals negative 3 bracket 6 multiplied by 2 minus 3 all to the power negative 3 over 2. 6 multiplied by 2 equals 12. 12 minus 3 equals 9. So it's a negative 3 multiply 9 to the power negative 3 over 2. By using the calculator, the answer is negative 1 over 9. We study example about the second rule. We have a special case about this rule. So we can take this as another rule or separate rule. If y, or we can say d by dx, square root of f of x, so what is the derivative of square root? Equals 1 over 2 square root of f of x, multiply the derivative of inside the radical, multiply by f of dash x. For example about this, for example, d by dx is square root of 6x minus 3. What is the difference between this question and that one? This 1 over, but the rule is direct d by dx square root. So what is the answer of this one? The answer is 1 over 2 square root of 6x minus 3. multiply by the derivative of inside the function, inside the root, multiply by the derivative of inside the root. So multiply by 6x minus 3, its derivative is 6. We can simplify more, divided by 2, 1, divided by 2 equal 3. Then the final answer of this one is 3 over square root of 6x minus 3. We take example about the second rule. Look at this example, differentiate 9e to the power. The rule is that d by dx. If we have a constant like k e to the power f of x, k is constant, so we keep it outside, so the answer is k e to the power f of x multiply the derivative of the power of e, which is f of dash x. So the solution of this one is d by dx 9 e power 3 minus x. Looks like 9 is k, the constant. So the answer is 9. The derivative of e is the same, e power 3 minus x. Multiply the derivative of the power. The derivative of 3 is 0, the derivative of negative x is negative 1, but it's better to put it in bracket. What is the final answer in simplest form? Negative 1 times 9, it's negative 9, e power 3 minus x. We take example about the third rule. This example about the third rule. d by dx ln f of x. The answer is the function down, so it's f of x, and the numerator is the derivative of denominator, which is f of dash x. The solution of this one is that d by dx 5x minus 4. The answer is fraction. This function comes down, 5x minus 4, up the differentiation of the denominator. Differentiation of 5x is 5, minus 4 cancel. Take care, don't cancel 5 with 5, because this is 5x minus 4, it is not 5x only. So not possible to cancel 5 with 5. So this is the answer. We take example about the fourth rule. We need to study 3 special cases. Special cases. The first one is that d by dx is square root of x. It's 1 over 2 square root of x. The second special case, d by dx e power x, which is e power x. The third case is that d by dx ln x, it's 1 over x. Now we need to take example about the fourth rule. This example talk about differentiate x cubed ln x. This is a product, x cubed multiply ln x. So we can say this is the function f and this is the function g. And this is the product of two functions. Remember the formula or the rule, d by dx, f multiply by g. It is the first multiply the derivative of second plus the second multiply the derivative of first. The solution of this question is that this is f, so we find f dash, the derivative of the first, x cubed, it's 3x squared. We find g dash, the derivative of the second, ln x, it's 1 over x. Then we apply the rule. So d by dx x cubed multiply ln x. Remember, the first one is f, the second one is g. So it is f g dash. F is x cubed. Multiply g dash, multiply 1 over x. Plus g is ln x. Multiply f dash is 3x squared. We simplify. X cubed and x divided by x1 divided by x. So it becomes x squared because we subtracted the power. So the answer of the first term is that x squared plus. It's better to bring this in front of ln. So it's a 3x squared ln x. Now we take example about the fifth rule. Differentiate e power negative 2x over a square root of x plus 1. What is the formula of the quotient rule? That d by dx f over g equals denominator squared and then g, the denominator up, multiply f dash minus, take care, minus f g dash. So we can let this one is f and this one is g. So let the numerator is the function f and denominator is g. What do we need? We need f dash and g dash. So we write here f dash. The derivative of e power negative 2x, it's e power negative 2x multiply the derivative of the power negative 2. In simplest form, negative 2 e power negative 2x. G dash, the derivative of square root. So we took this as a special case. 1 over 2 is square root of x plus 1 multiply the derivative of inside bracket, it's 1. So finally it's 1 over 2 is square root of x plus 1. Then we apply the rule. So the solution d by dx e power negative 2x over a square root of x plus 1 g squared. When you square this one, the square root will be cancelled. So it's x plus 1. And then we move this up. This is g. G is a square root, notice. So it is a square root of x plus 1. Multiply f dash. F dash is negative 2. Negative 2 e power negative 2x. The derivative of f dash negative 2 e power negative 2x. Minus, this is the rule. Take care, minus of the rule. Minus f which is e to the power negative 2x. Multiply g dash. This is g dash. So take care. This is g dash. It's 1 over 2 square root of x plus 1. We simplify this. So this answer in simplest form, it's x plus 1. We bring a negative in front, so it's a negative 2 e power negative 2x square root of x plus 1. Minus, okay, it's e power negative 2, so we can write 1 over 2 square root of x plus 1 multiply e power negative 2x. We can simplify more by multiply up and down by square root of x plus 1. And we can take e power negative 2x as a common factor. So, but this is enough for this example. I hope you understand this lesson. Thank you.